from these two pictures, you can calculate this by the formula P is equal to F upon A. Okay, you do try yourself, then consult me. Okay, I don't take more time now. I think you got the process. Now here is another. When a brick is placed on its widest base, solution. Okay, look here. Solution 25 meter. Uh, this is area. Force is 2.5 in force area. 2.5 Newton, and area is directly converted into meter square. It came 0.025 meter square, and answer came 100 Newton per square meter or Pascal. In placed on its widest base. That means base is very wide. Base is very wide means in second, in first condition, very wide. Base is very wide, and in second condition, from first 100 Newton meter square came. From second, when brick is placed upright means this upright. Then area came 0.005 meter square, and from formula answer came 500 Newton per square meter. 500 Newton. This 500. In first condition 100, in second condition 500. Therefore, in this way we can conclude that area relates negatively to the pressure. Area is increased, pressure will decrease. Highest pressure is exerted by sharp edge. Look here. To exert high pressure, maximum pressure, the edge is made very sharp, fine. Look here. In the blade, if we sharpen the blade, it can cut any vegetables easily. That means maximum pressure is developed. In the pin, thumb pin, needle-like part is here. Sharp, it can be placed on the notice board easily. But if the tip part is blunt, not sharp, we cannot press the pin on the board. Look here, another shoe. At the bottom of the shoe, at the sole of the shoe, there are three piercing part. It is made for slippery area. In slippery area, if we wear this type of shoe, then we don't slip on the ground. We can walk easily. To the football player, this type of shoe is designed. Because they have to run. While running, they should not fall on the ground. Therefore, at the sole part of the shoe, this type of grip are made to minimize to minus the area of the sole. Now, low pressure. To decrease pressure. Look here. Here is one sledge. Here is sledge. Two sledge players are playing sledge. And area of the sledge is very big. It is made long. By making long, area to press the ground is increased. As the area is increased, they will not grip on the ground. They can slip easily on the snowy land. This is low pressure. To develop low pressure, area is increased. In the tractor, in Tarai region, most of the farmers use tractors to carry cereals or that coconut, sorry, that what is called that sugar cane, etc. from the field. To go up to the field, the road is muddy. In muddy road, the tractor does not trap because the tire of the tractor is very flat. Due to flat tire, the tractor does not trap in muddy road. Therefore, to minimize the pressure, to minus the area of the tire is increased. Area is increased to minimize the pressure. Look at your bag. In your bag, shoulder pad will be inserted in belt. Area of the shoulder pad is more than the belt. Then we don't feel hurt while carrying our books. Therefore, bags are made flat. Look here in another school bag. In school bag, this shoulder belt is made flat. Due to uh, mm, flat area is increased. Due to more area, we don't feel more hurt while carrying many books. These all are to minimize pressure. First one is to increase pressure. To increase pressure, we minimize the area. Tip of the needle, blade of the edge of the blade, or sole of the football player shoe. To minimize area, this process is done. To minimize pressure, area is increased here in this all. Now look here. In which of the following case is the child exerting least pressure? Least means low pressure. Minimize pressure. On the ground, look here. First position, knee and hand. Second, sleeping. Third, one leg. Fourth, two legs. By which position the child or the student exert very least pressure? In which position? A, B, C, or D?
Sir, in B1, I think.
In B, least pressure. Yes, I am saying least pressure. Okay. Other students, other. Okay, can you guess? In which position?
Sir, B.
B. Others? Others? Once I will take your attendance, I'm getting confused here. Okay, wait, okay. Anisha, Sandeep, Anisha, Arun, then Vikas, then Sarana, Kamal. Okay, Kamal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. B, yes. In B position, least pressure will be exerted. Then in which position highest pressure will be exerted?
In C, sir, C.
In C, yes, C. In C, least pressure is exerted because area is least. Okay. Look here. In which two spiders? One is spider, another is cockroach. If the body weight is same, If the body weight of two insects are same, then which insect will make deep footprints on the ground? Body weight.
Sir, spider. Spider, I think. You know.
Which
Yes, sir.
insect?
That is spider. Yes.
Spider. Okay. How can you guess that spider leaves less footprints? How can you guess? By scientific view, you have to give your logic. Okay. Body weight is same. Cockroach and spider same. Land is same. While walking, which insect will leave more footprint and which insect will leave less footprints on the ground?
Both are same, I think.
Same. Okay. In this condition also, you have to look to area. Which insect will cover less area will leave dark footprint because it will press on the ground in high pressure, and the area which is covered more, which insects covers more area while walking, it will produce less pressure. Confused? Yes. I said body weight is the same, that means force is same. Now you have to count leg. In spider, 1, 2, 3, 4, 8 legs are there. Eight legs. Okay, 8 legs. In cockroach, 1, 2, 3, 4, 5, 6. 6 legs and 8 legs. Which insects will cover more area? Hello? Which insect will cover more area on the ground?
Sir, spider.
Spider is because it has 8 legs. Cockroach has 6 legs. Therefore, spider will make less footprint. Cockroach will make more footprint because cockroach will press the ground with more pressure. Area is less in cockroach. Area is more in spider. Okay. Now, uh, atmospheric pressure. Atmospheric pressure. Look to your book also. Okay. What is this? Atmospheric pressure. Okay. Uh, Atmosphere means the layer of the air around the earth is called atmosphere, and pressure developed or pressure exerted by the atmosphere, by the air to the ground of this earth is called uh, atmospheric pressure. Around us, from every side, air is pressing our body. Atmospheric pressure. And one amazing thing is that we are in the effect of we are in the effect of uh, uh, 100 elephants weight pressure from the atmosphere. In our body, 100 elephants are pressing. That much pressure is bearing we all. we all are bearing 111 body weight uh, force. Even then, we don't feel pressure because we are habituated. We are habituated by this. But if after that, if atmospheric pressure is increased a little bit, only then we can feel. Till now, we don't feel 100 elephants body weight pressure from the ear because it is not changing. It is not changing. From the birth, we are feeling that. From the history of the earth, we are feeling that. Therefore, we are not feeling so. Like earth is moving around the sun, we don't feel we are moving around the sun because there is no any change in the movement of the earth. If there is any a little bit change in the movement, we feel. Therefore, we can feel earthquake. That is change in movement. Like that, atmospheric pressure is very high and we are not feeling due to no change. Now look here, the weight of the in air column of the height of the atmosphere and area 10 into 10 centimeter is large as 1000 kg. That means air also gives pressure to indicate that this sentence is quoted. Look here. Why do not we get crushed under this pressure? Look here. One example is given here. 1000 kg weight, but we are not crushed. Reason? The pressure exerted by the fluid in our body is equal and opposite to the atmospheric pressure. From the fluid inside our body also exerts same amount of pressure. Therefore, they cancel each other and we don't feel. Okay. Look here. Water does not fall. The glass is filled with water and inverted by covering its mouth with cardboard. But water does not fall because from all around the glass, air is giving pressure. Air is exerting pressure and pressing to the cardboard. To the glass also, air is pressing, but glass is hard. Therefore, it cannot be moved. But cardboard is soft and by the pressure from the down part, cardboard is pressed upward and mouth is blocked. Therefore, water does not fall. Air exerts pressure in all directions, not in upward direction only. In all directions, air exerts pressure. Cold water, look here. One uh, can is metal can, okay? This is tin made with a thin sheet of metal, that is tin. In tin container, water is boiled and at the hot condition, at the evaporating condition, lid is tight. Lid is covered and left. Then cold water is poured outside the this tin. Due to cold water, what happens? Inside pressure becomes low. Inside pressure becomes low. Low pressure. Inside pressure becomes low because volume is decreased due to cold. Inside pressure is low, then outside pressure is high. Outside pressure is high. Therefore, from high pressure to low pressure, it will press from all side. From all side, atmosphere will press the tin, and the tin shape will be different. Tin shape is damaged, is shown in the picture. This is due to atmospheric pressure and from all directions, from top side also. From all directions, air is pressing from all directions, okay? From all directions. From downside also. From bottom part also, air will press the container. From here also. From all directions, air will press the container. Then in this way, pressure is exerted by atmosphere from all to the all directions. And let's move to next facts about pressure. Factors affecting atmospheric pressure. By which factors atmospheric pressure is changed? One is altitude. Altitude means altitude means height. Altitude means height. Height. In hilly area and in Tarai area. That is change in altitude. In hilly area, altitude is high. Then altitude, if the altitude is more, then pressure will be less because at altitudes the layer of air will be less. The layer of air will be less. Weight of the air will be less. Therefore, and atmospheric pressure will be less, decrease. In mountains, pressure will be less because that land will be pressed by less amount of air. Then temperature. By the temperature, volume of the air is increased. Volume of the air is increased. Volume of the air is increased, then area will be increased. Area is increased, pressure will be decreased. Therefore, air expands on heating and becomes less dense. Therefore, atmospheric pressure will be decreased with increase in temperature. Or you can say in another way, temperature increases volume. Increase in volume means increase in area also. Increase in area also. Increase in area means in pressure, opposite effect, decrease in pressure. In this way, due to temperature also, pressure is changed. Another humidity. Humidity means amount of water vapor contained in air. Amount of water vapor contained in air is humidity. Then what happens? Water vapor present in air. Water vapor present in air that is lighter than air. Humidity makes it light. Humid air is lighter than dry air. Lighter means not so heavy. In this condition also, pressure will be decreased. In another way, you can say water vapor present in air does not give air to press downside. It disturbs. Water vapor present in atmosphere disturbs the air to press the ground and weight becomes low. Therefore, low weight means low force. Low force means less pressure. Therefore, by humidity also pressure will be decreased. Humidity increases, pressure decreases. Humidity decreases, pressure also decreases. Sorry, humidity increases, pressure decreases. Humidity uh, decreases, pressure increases. Opposite effect. Altitude has opposite effect. High altitude, low pressure. Low altitude, high pressure. Altitude, opposite effect. Temperature also opposite effect. High temperature, low pressure. Low temperature, high pressure. Opposite. Humidity also opposite. More humidity, less pressure. Low humidity, high pressure. In this way, these are three main factors which affect the atmospheric pressure. Okay, uh, these are few examples of uh, advantages of atmospheric pressure or benefits or applications of atmospheric pressure. While filling medicine in syringe, we pull piston out. When we pull piston out, inside part, containing part, that volume becomes more. Volume is increased. Volume increased, low pressure. Low pressure means from outside high pressure. Liquid or medicine go inside the syringe. We push piston out. We push piston out. Piston out means area is vacuum area is more. Then volume more means low pressure, and in low pressure from high pressure, this medicine or water inserts. This is one application of air pressure. And another, while eating juice from straw pipe, while drinking juice. Okay, when we shock air inside the pipe, there will be low amount of air. Low amount of air means there is low pressure. From glass, in glass there is high pressure because atmospheric pressure is pressing the glass, and due to outside liquid goes inside the mouth because we made pipe pressure low by pumping out air. Another, soccer book. It is wall. I think this type of tool is not so much utilized in our daily life. It is a tool which can be shocked on the wall. This wall is very smooth like a glass. This part is attaching part. This black is rubber rubber part. We press this inside, and inside is made, and here is low pressure, and from outside it will reach the this pump. It will stick to the wall. It will stick to the wall. This is called socket. And in this hook, we can hang objects.
Online ra thôi.
Okay. Okay, now importance of atmospheric pressure. Here are some examples. To fill ink into a fountain pen. In fountain pen, we can fill ink due to air pressure. Due to atmospheric pressure, we fill ink due to the atmospheric pressure. To fill a syringe, to fill syringe with medicine also atmospheric pressure is beneficial or very much important. To fill air inside tube of the cycle. To inflate a bicycle tube with a pump. Atmospheric pressure. Look, a small child can pump very deep water from tube well because atmospheric pressure helps, and this child will press the handle, and due to atmospheric pressure water will come out easily. To walk easily on the ground, due to uh, atmospheric pressure, our body is also pressing down. Our body is also pressing down due to atmospheric pressure, and due to gravity also. And while walking, our shoe will grip the ground, and we be easy to walk on the ground. In this way, okay. Today's class up to now, I think I took a little bit more today. I started a little bit late also. Okay, up to here for today, and all of you are suggested to read the topic, to read the chapter once thoroughly. And if you get any confusion or misunderstanding, and you can follow me in next class. Okay. Then now I have to close my today's class. Okay. Thank you, class.
Bye
Bye
sir.
bye.
Bye.
Bye bye sir.
Bye.